All right, now in chapter 2, we want to start talking about the equations of motion in one dimension. The equations of motion in one dimension help put all of the stuff we've been talking about together into a cohesive form. So there are basically two different scenarios. And if we look at the second scenario, it collapses to the first when we set the acceleration to 0. All right, so the first situation is constant velocity. So if you're moving at constant velocity, you've got this one simple little equation. All right, one simple little equation. X is vt times x0, constant velocity. All right, if you're moving at that's a great A. If you're moving at constant velocity, that means the acceleration is 0. Right? Acceleration 0, constant velocity, x equals vt plus x naught. If additionally you have 0 velocity, well, it's a kind of uninteresting situation because then x is always the same position, x naught, right? So this describes your x position under constant velocity. So let's add in acceleration. Now if we go to constant acceleration, which is as far as we're going to go in this class, if we go to constant acceleration, then velocity is acceleration times time plus your initial velocity. So v naught is your initial velocity, x naught is your initial position. Your velocity at any time is acceleration times time plus v naught. Under constant acceleration, your position at any time is 1/2 the acceleration times time squared plus your initial velocity times time plus x naught. So let's think about what if acceleration goes to 0? Well, then v is v naught, you're at constant velocity. If acceleration goes to 0 here, then x is v naught t plus x naught, and you're back up to the constant velocity equation, right up here. Average velocity. Your average velocity is your current velocity plus your initial velocity over 2. That's your average velocity. All right. And the last little equation that sometimes becomes important is v squared is v naught squared plus 2a onto x minus x naught. All right. So these are our 4 equations. This one up above is really kind of redundant because all you have to do is set the acceleration to equal to 0 and you get this equation. So these are your 4 equations of motion in one dimension. If we want to stick in a different start time other than t equals 0, all you have to do is substitute t minus t0 for t, and you get the equations that look exactly like this, right? So these are the same equations. All right, so back to this form. If you look at this set of graphs, they have a little story to tell. One is here the velocity is changing, right? Velocity of changing. Because the velocity, this is position versus time. And you can see the velocity is changing. We're accelerating, we have some velocity. Velocity is changing. Why? Because velocity is the slope of this line. We'll get to that later. This position versus time, velocity is the slope. So you can see there's some acceleration, then there's some deceleration. All right, so this part we're accelerating here, you can see that the velocity is increasing, and it gets to here, and then the velocity is flat. So there's no acceleration from this point to that point, and then we decelerate. All right, so the velocity slows down until we hit 0. Here is the acceleration versus time. Acceleration is nothing other than the slope of velocity. All right, velocity is the slope of position with respect to time. Acceleration is the slope of the velocity curve with respect to time. So here we have positive acceleration, no acceleration, and negative acceleration. Does that make sense? Acceleration is the slope of the velocity curve. Velocity is the slope of the position curve. So when you go to solve one of these problems, All right, here are the techniques. Make sure you understand what physical principles are involved. That kind of equates to make sure you know what equations to use, and is it forces, is it position, is it acceleration, is it constant velocity, right? Make a list of what you are given or can be inferred from the problem. Sometimes we don't say things like starting at position X, right? Sometimes we don't say things like starting at time t equals 0. And you have to understand that in the English of the problem, we have those quantities. Uh, Third part, identify what needs to be determined in the problem, right? What are you trying to find? Find an equation or set of equations to help you solve a problem. Put the knowns in, along with their units. Make sure you track the units, because units are going to be very important in understanding what's going on. And last, make sure your answer is reasonable, that it makes sense. All right. All right. That's it for this portion of Chapter 2.